Hey everyone, welcome back to the channel. You know, when we look up at the night sky, we often see it as this serene and unchanging tapestry of stars. But the universe is a dynamic place, and Earth is not immune to its cosmic chaos. We're talking about asteroids, meteors, and comets. Those celestial wanderers that have left their mark on our planet in some pretty dramatic ways. Over billions of years, Earth has been bombarded by these space rocks, some leaving behind scars that are still visible today. These impacts, while rare, are a stark reminder of our planet's vulnerability in the vastness of space. So, buckle up as we explore some of the most significant meteorite impacts in Earth's history, from the cataclysmic event that wiped out the dinosaurs to more recent encounters that have shaken our planet and reminded us of the awesome power of the cosmos. Let's start with the big one, the granddaddy of all impacts, the Chicxulub event. This cataclysmic event is one of the most significant in Earth's history, marking the end of the Cretaceous period and the extinction of the dinosaurs. Picture this, 66 million years ago, an asteroid estimated to be about 6 miles wide slammed into Earth near the present-day Yucatan Peninsula in Mexico. This wasn't just any ordinary rock, it was a colossal space projectile traveling at an incredible speed. Now, 6 miles wide might not sound like much on a planetary scale, but this thing packed a punch. Imagine an object the size of a city moving faster than a bullet, carrying with it the energy to reshape the world. The impact released an unimaginable amount of energy, equivalent to billions of atomic bombs detonating simultaneously. The explosion was so powerful that it created a crater over 90 miles wide and 12 miles deep. The immediate aftermath was catastrophic. Earthquakes that would make the Richter scale shiver in its boots, tsunamis that could drown entire continents, and wildfires that raged across the globe. The initial destruction was just the beginning of a series of apocalyptic events. But the real devastation came from the long-term effects. The impact set off a chain reaction of environmental changes that would alter the course of life on Earth forever. The impact ejected trillions of tons of debris into the atmosphere, shrouding the planet in a thick veil of dust and sulfur. This debris blocked sunlight, leading to a dramatic drop in global temperatures. This impact winter blocked out the sun, causing temperatures to plummet and photosynthesis to grind to a halt. Without sunlight, plants couldn't survive, and without plants, herbivores and subsequently carnivores faced starvation. The food chain collapsed, and with it went the dinosaurs, along with about 75% of all plant and animal species on Earth. This mass extinction paved the way for the rise of mammals and eventually humans. The Chicxulub impact is a sobering reminder of the destructive power that lurks in the depths of space. It shows us that our planet, despite its size and resilience, is vulnerable to cosmic events. It's a reminder that even the mightiest creatures on Earth can be brought low by a cosmic bullseye. The story of the Chicxulub impact is a testament to the fragility of life and the ever-present potential for sudden dramatic change. Now let's fast forward to the 20th century and journey to the remote Siberian wilderness for the Tunguska event. This mysterious and catastrophic event has puzzled scientists and researchers for over a century. On June 30th, 1908, a massive explosion ripped through the air above the Podkamennaya Tunguska River. The sheer force of the blast was unlike anything ever recorded in human history. The blast, estimated to be about 1,000 times more powerful than the atomic bomb dropped on Hiroshima, flattened over 80 million trees across an area of 830 square miles. The devastation was so extensive that it left the forest looking like a wasteland. Witnesses described a blinding light, intense heat, and a shockwave that knocked people off their feet hundreds of miles away. The event was so powerful that it was felt as far away as Europe and Asia. But here's the mystery. There was no impact crater. Despite the massive explosion, no evidence of a meteorite impact was found on the ground. Scientists believe that the Tunguska event was caused by an asteroid or comet that exploded in the atmosphere before it could hit the ground. This theory is supported by the lack of an impact crater and the widespread destruction. This type of airburst explosion can be even more destructive than a direct impact, as the energy is released over a wider area. the force of the explosion is dispersed, causing extensive damage over a large region. The Tunguska event is a stark reminder that even relatively small objects from space can pose a significant threat to our planet. These cosmic intruders can cause unimaginable destruction if they enter our atmosphere, and the fact that it happened in such a remote area is a chilling reminder of how vulnerable we are to these cosmic events. It raises important questions about our preparedness for future impacts and the need for continued vigilance in monitoring the skies. Now let's jump ahead to the 21st century, a time of rapid technological advancements and unprecedented global connectivity. Amidst this progress, an event occurred that really shook us into the 21st century, the Chelyabinsk meteor. On February 15, 2013, a meteor about 66 feet wide entered the Earth's atmosphere over Chelyabinsk, Russia, catching everyone by surprise. The meteor, traveling at a speed of about 40,000 miles per hour, exploded in a blinding flash of light, brighter than the sun, releasing an energy equivalent to about 440,000 tons of TNT, which is roughly 30 times the energy released by the atomic bomb dropped on Hiroshima. The explosion created a shockwave that circled the globe twice, a testament to its immense power. The shockwave shattered windows over 200 square miles, causing widespread damage to buildings and infrastructure. Over 1,500 people were injured, mostly due to glass from shattered windows, highlighting the vulnerability of urban areas to such events. The Chelyabinsk meteor was a wake-up call, a stark reminder of the potential dangers lurking in space. It showed us that even relatively small asteroids, which we might not consider a threat, can pose a significant danger to populated areas. The good news is that events like Chelyabinsk are relatively rare, occurring perhaps once every few decades. But the bad news is that our current detection systems are not very good at spotting these smaller objects until it's too late, leaving us vulnerable. The Chelyabinsk meteor highlighted the urgent need for better detection and tracking systems to monitor the skies more effectively. These systems would give us more warning time to prepare for potential impacts, potentially saving lives and reducing damage. Now, let's travel back in time to about 2 billion years ago to South Africa, where we find the Redefort crater, the oldest and largest known impact structure on Earth. This colossal crater, originally spanning about 186 miles in diameter, was formed when an asteroid, estimated to be about 6 to 9 miles wide, slammed into Earth. The Redefort impact was so powerful that it literally warped the Earth's crust, creating a dome-shaped uplift in the center of the crater. The impact also released enormous amounts of heat, melting rock, and creating vast deposits of gold, platinum, and other valuable minerals. The Redefort crater is a testament to the incredible power of asteroid impacts and their ability to reshape our planet. It's also a reminder that these events, while destructive, can also have a profound impact on the geological and even economic landscape of our planet. Now let's head over to Arizona, where we find the Barringer crater, also known as Meteor Crater, one of the best preserved impact craters on Earth. This relatively young crater, formed about 50,000 years ago, is a popular tourist destination and a reminder of the destructive power of even relatively small asteroids. The Barringer crater was formed when an iron-nickel asteroid, estimated to be about 150 feet in diameter, slammed into the Arizona desert. The impact released an energy equivalent to about 10 megatons of TNT, excavating a crater about 3/4 of a mile wide and 570 feet deep. The Barringer crater is a popular destination for scientists and tourists alike, offering a glimpse into the violent history of our planet and the forces that have shaped it. Finally, let's journey to Ontario, Canada, where we find the Sudbury Basin, one of the oldest and largest impact structures on Earth. This massive crater, formed about 1.85 billion years ago, is believed to have been created by an asteroid or comet about 6 to 9 miles wide. The Sudbury impact was so powerful that it created a molten sea of rock that extended for miles around the impact site. Over time, this molten rock cooled and solidified, forming a rich deposit of nickel, copper, and platinum group metals. The Sudbury Basin is a prime example of how asteroid impacts can have both destructive and creative consequences. While the impact itself was undoubtedly catastrophic, It also led to the formation of one of the world's richest mineral deposits, which has had a significant impact on the local and global economy. From the dinosaur-killing Chicxulub impact to the more recent Chelyabinsk meteor, these events remind us that we live in a cosmic shooting gallery. But they also highlight the resilience of life on Earth and our ability to learn from these events and prepare for the future. By studying these impact craters, we gain a deeper understanding of the forces that have shaped our planet and the history of our solar system. And by developing better detection and tracking systems, we can work to mitigate the risks posed by these celestial wanderers. So the next time you look up at the night sky, remember that it's not just a beautiful tapestry of stars. It's a dynamic and ever-changing arena where cosmic events can have a profound impact on our planet and our lives.